Hi everyone, hope everyone is well and safe there. My name is João Pedro. I'm a mechanical engineer graduated at Cefet University. So this presentation had to be made considering the COVID-19 pandemic crisis, and it will address a technical and economical analysis of a grid-connected PV system in the state of Rio in Brazil. The authors of the article are shown here. So that's me, Priscila, Pinto, and Marcos Curi. So the paper considers two different scales of utility. So that would be a residential and a commercial scale. Both scenarios proved to be economically viable, with paybacks occurring less than 7 years. And for the residential PV system, it is expected to provide around 300 kilowatt peak per month, which is the average consumption of a middle class family in Brazil, and saving a total of about 43,000 Brazilian reais, which is close to $8,000. And the commercial utility should produce more than 1,300 kilowatt hour per month, and a cumulative saving of about 200,000 Brazilian reais, which is close to around $35,000, considering 2020 currency rate, should be expected over the lifetime of the system, which is 25 years. First, I would like to show you a market overview comparing installed capacity of renewables and non-renewables. So as we can see here from IRENA report, it is evident a decrease in non-renewables share. So this trend leads basically to a capital interest in developing new technologies for renewable sources, which includes PV tech. Also, with higher demand across the globe, it is expected the prices to drop down, as I will show in the next slide. So several companies are tracking down costs over the years, and here Lazard's report shows us that utility scale PV system decreased around 89% in the last 10 years, and the levelized cost of energy of PV systems just 10 years ago was nearly $360 per megawatt installed. And 2019 research indicates that an investor would pay around $40 per megawatt hour installed. So considering a scenario of breakthrough technologies and a higher demand, prices should go even lower in the following years. Moving on to PV fundamentals, in order to determine the viability of the system, two aspects should be taken into account. So the region, solar resource, and which PV technology to use. So figure 3 here shows us an average global horizontal insolation over a year, but a further analysis must be made considering specific aspects such as presence of shades, average rainfall, azimuth position, and etc. So from here we can see Brazil is in a pretty good spot comparing to leading countries such as US or Europe, specifically Germany and China also. And regarding the PV technology, it has to be known if the system will be connected to the grid or it will be an isolated system with batteries. Also, the type of technology used in the solar cells is a very important aspect. For this scenario, we are considering for both systems to be grid connected, so we don't need batteries here, just the PV modules, inverter, the net metering, and all the systems should be connected to the grid. So for this paper simulation, a 5 kilowatt hour per day installation was assumed, which is present in most of Rio's area. So the methodology used to determine the viability is based on the initial investment and energy output provided by the system. PV costs in Brazil for the grid-connected system should be around 6 Brazilian reais for the residential system and around 4 Brazilian reais for commercial systems. The capacity of the residential and commercial of this study is 2.7 and 11.7 kilowatt peak, which gives us here about 10 modules, and here it's something around 36 modules. So comparing with prices from Greener and AHK 2017 market research, small PV systems, so minor than 5 kilowatt peak, costs almost 8 Brazilian reais per watt peak installed. And for a medium-sized system, which is the considered for a commercial application, costs between 6 and 7 Brazilian reais. So in just 3 years, we had a considerable decrease in overall prices. So to understand the PV profits, the cash inflow can be obtained knowing the annual energy produced, which depends on the system nominal output, which will differ from the commercial and the residential application. The performance ratio, which is industry standard 70%, 75%. The in-plane irradiance for Rio, we assume to be 5 kilowatts per meter square, and G here it's the Earth reference irradiance. So multiplying the energy output by the retail price of electricity, which is pretty high in Brazil, same as California in the US, and multiplying by the electricity taxation. So every year we expect the electricity in Brazil to increase around 9%. And of course, there is a degradation factor. So the derating factor of the system is expected to be minus 0.5%. So let's say you have a module of 16.5% efficiency. So the year after operating, this should be 16, and the year after 15.5, and so on. And of course, we have to consider inflation here, and this is a very optimistic inflation considering Brazil's economy, so 4% per year. And the system is expected to last a minimum of 25 years. We have some cases of PV systems still working for like 30 or 35 years. So this graph here shows the net present value for the residential PV system, and we can assume it to be profitable with a discount rate below 17%. So when we have a positive NPV, that means the investment it's viable basically. So the average Selic rate in Brazil since the last 20 years at least, it's about 12%. So here if we consider the 12% rate, the system is for sure viable. So this graph here shows us the payback for the residential system. The expected payback should occur in 6 years of operation, and we can see here the break-even point. So the initial investment, it's something around 13,000 Brazilian reais, and with the cash inflow, this is the moment the initial investment is paid. So it's a very good scenario. World's average, it's around 7-8 years, because the payback relies a lot on the solar resource. So moving on to the commercial PV system, we expect a more feasible project due to the lower costs mainly. So NPV, it's positive below 20% of discount rate. So as I mentioned before, Selic, it's around 12%. So we definitely have a profitable investment here. Payback of the commercial system should occur in less than 5 years. So this trend here shows us the moment that the owner had to replace the inverters. So at the 10th year, with the inverter replacement, we can expect a negative balance, but we can see that from the 5th year to the 10th year, we have a positive cash inflow, so the inverter replacement would pay itself. So the conclusion of this paper is that Rio and most of Brazil area provides a great solar resource, and the technology costs break even in less than 7 years, for a system expected to last 25 years. Further studies regarding distributed generation policies should be taken to implement an effective transition from currently net metering to a feed-in tariff system. So leading to more acceptability among the population. Thank you for your attention, and I'm at your disposal for questions and discussions.